Hi, everybody. I want to take you through one more example in section 2.10 of our text. And let's get right down to it. Example 3. A company finds the demand Q in thousands for their kites to be Q equals 400 minus P squared at a price of P dollars. Find the elasticity of demand when the price is $5. That's one question, and then the next question is find it when the price is $15. So that's two separate things. And then find the price that will maximize the revenue. You want to maximize revenue, so you want a whole bunch of stuff here. So first, I want to remind everybody that elasticity of demand is capital E, and that's equal to the absolute value of P over Q dq dp. So now we know P is just P. We got a formula for Q in our problem, and then we just got to figure out the derivative dq dp. So let's get to it. Where are we here? Okay. So so P is P. We see that Q is 400 minus P squared. So that means dq dp just equals 2p. Very simple, because you have dq. Now, why is it 2p, not negative 2p? There's a minus p squared. Well, we're taking the absolute value of everything, so everything is going to be positive. And now we could easily figure out E. E is very simple. E, oops, E is just P over Q, dq dp. Well, P is just P. Q is 400 minus P squared, which we're given. 2P is the derivative that we figured out. And putting it all together, we get E is equal to, and again, don't get the absolute value. It's the absolute value of 2P squared over 400 minus P squared. And now, all I got to do is plug in P equals 5, get my first answer, plug in P equals 15, and get my second answer. It's as simple as that. So plugging in P equals 5, we get E of 5 is equal to 2 times 5 squared minus over 40 minus 5 squared. Absolute value, well, it's positive anyway, but it comes out to be approximately 0.133. Now, the demand is inelastic when the price is 5 because 0.1 is less than 1. And at a price of $5, a 1% increase in price would decrease demand by only 0.133%, which is not a lot. The revenue could be raised by increasing prices, and that's what we saw in that original table. That if the demand is inelastic, meaning that E is less than 1, then the revenue increases when you increase the prices. Now, as far as the next case, all we got to do is plug in P equals 15. And for that, we get 2 times 15 squared over 400 minus 15 squared, which comes out to approximately 2.571. You can just plug that into a calculator. And since it's greater than 1, demand is elastic when the price is 15. So if the price is 15, a 1% increase is going to decrease the demand by is going to decrease the demand by a whopping 2.5. By the way, increase in price always decreases demand. We mentioned that that's why the slope always winds up being negative, but we absolute value of it. But we're looking at the revenue, not just the demand. The demand can go down, the revenue can go up. That's possible. We had that in the first case of E of 5. But here, it's going to go down a lot, and the revenue is going to be decreased if you increase the price, which would mean it would increase if you decrease the price. Alrighty. So now for the last part, we wanted to find the maximum. The last part was we wanted to find the maximum revenue, and the maximum revenue comes when E is equal to 1. So to maximize the revenue, we're going to solve for when E equals 1. And so we're going to take two. We're going to take the formula that we got, 2p squared over 400 minus p squared. We're just going to set that equal to 1, and then we're going to solve for p. So we get 2p squared is equal to 400 minus p squared, and which then bring the p squared over to the other side. 3p squared equals 400. Divide both sides by 3. P is equal to the square root of 400 thirds, which is approximately 11.55. So the if you want the best revenue, you want to set the price at $11.55. That's a phenomenal. I can't begin to stress how powerful that is. If you're in business, you want to know what price should you charge. You might think that you're doing yourself a favor by charging $10 and having more people buy it, but you actually make more money when you charge $11.55 and less people buy it. Fewer people. So this is, and you may say, hey, if I'm charging 11, why don't I charge 12? Well, 12 will not be as much. 11.55 is that's your maximum revenue, and that is a phenomenally powerful use of the calculus. So, everybody, it's been loads of fun, and we will see you all next time. Bye, everybody. Bye.